Hello, and welcome to the STAT244 group project video for me, Jeremy Wood, Michael Huber, and Will Renken. Now what you can see here is an Excel spreadsheet showing the data we collected for this video. We took 40 samples of regular and premium gas prices from the Portland area from 40 different gas stations. Now what we're going to do with this information is a t-test for correlation to see if there is a significant correlation between the price of regular and premium gas at any given station. If we find that there is a correlation, we will then use the linear model given from the t-test to create a prediction interval of outcomes y, or premium gas price, for a given regular gas price x. We collected this data through the website Gasbuddy.com, which has recent gas prices at all posted stations in the area. We used the map tool shown here to select our 40 samples. We did this simply by selecting 40 different stations and recording their gas prices. While this may not seem random at first, as obviously we picked the stations ourselves, the geographic location of the station should not have any effect on the relationship between the regular and premium gas price at that station. So for the purpose of this project, it is random. I will now pass the torch over to my colleague who is going to explain how to do the t-test.
My name is Renken, and I'm doing the t-test for correlation. This is the ANOVA output for our data. The R value necessary to perform the t-test for correlation is here. The actual test statistic t is found using this equation here. The t-statistic itself is right here. We compared this to the critical value for an alpha of 0.05 and degrees of freedom 38. The critical value found using those is here. Since the t-test statistic is larger than the critical value, we can reject H0 and conclude that there is sufficient evidence to support the claim of linear correlation. The regression equation can be based off of this equation here. The regression equation can then be used to predict the price of premium gas based on the price of regular gas. For instance, if the price of regular gas is $3.95, the price of premium would be $4.18. The graph here is the graph of all of our data, including the regression equation as a line going through that data.
Hi, I'm Mike Huber doing the STATS244 gas price group project with Will Renken and Jeremy Wood. I'm doing the prediction interval. To find the prediction interval, we're going to need to find some numbers from Excel. To do so, we need to go to ANOVA to find our standard error. We need to find our y-intercept. We also need to find our slope right here. We also need to go in and do some descriptive statistics to find our mean, or x-bar, and we also need to find the sum of all the x's so that we can find the sum of the x's squared. Our standard error estimate from ANOVA is as follows. Our t-table distribution for 95% at 38 degrees of freedom is 2.024. Sum of all the x's squared is 24,087. Sum of x squared is 602.798. X bar is 3.88. X equals 3.75. Here's the following numbers in the equation needed to find the error. Once the error is found, I need to find y hat, which is y-intercept plus slope times x. Having found these numbers in my ANOVA, I was able to find y hat to be 3.96818. Having found y hat, I needed to add and subtract the error from it to find my confidence interval. Having done so, I found the confidence interval to be 3.90794 on the lower, and on the upper, 4.02841. What does this mean? That means With a 95% confidence, we can predict that a regular price of $3.35 will correspond to a premium price between $3.90 and $4.02. Thank you very much for watching our video. I hope you enjoyed it.